Now we'll look at central measures or means, finding a mean of a data set. So finding the middle of a data set or the center of a data set. You could have different measures of that. We will look at 3 common ones. So the first one we look at is median. So what is the median of a data set? That is the data in the middle in the following way. So let's say that we have a data set. We have thrown a die a couple of times. So we have gotten a 3, 1, 5, 2, and 6. So which one is in the middle? We don't mean this one, because we have to put them in order first. So we put in 1, 2, 3, 5, 6. Now the one in the middle is this one. So in this data set, the median is 3. Okay, but what would we have done if we have instead would have had one more data? So let's put one more. Yeah, instead of this one, we would have this data set 1, 1, 2, 3, 5, and 6. And which one is now in the middle? Yeah, it should be here, but there is no one in the middle. So you have to take the 2 in the middle, and you have to take the average of those. Now we haven't talked about average yet, but I surely know what average is. So take the average of these 2. So we add these 2 and divide by 2. So you got 5 divided by 2, 2.5. So in this case, the median is 2.5. So you see that the median don't have to correspond to any of the data in the dataset. Since it's 2.5, you can't get 2.5 on a die when you throw it. So 2.5, that's the middle of this dataset according to the median, and it's the middle of the first dataset according to the median is 3. So that's the first measure, and very crude measure of middle of a dataset. You just disregard almost all of them, just look at the one in the middle. The second measure of center we will look at is called the mode of a dataset. And the mode of the dataset is the most frequent of the data in the dataset. So if I throw a die now again, let's say I get 3, 1, 3, 4, and 6. In this case, the most frequent data is 3. So in this case, the mode is equal to 3. So that one is most frequent. But what do you do if you have, for example, 3, 1, 1, 3? Then we have 2 that's equally frequent. You have 2 3s and 2 1s. In this case, you could define differently. Some define the mode as having 2 values, it's both 1 and 3, and others define it as having no mode. So we will define it as having no mode, since the 2 that is the same. But of course, it's up to definition. So mode is the extremely crude measure. It just looks at which is the most common one. It doesn't care about the rest. Then we come to the final example, third example, average. It's a little bit more sensitive or sophisticated, you could say in some sense, than the other two. The other two are very crude, just disregard most of the data. Average takes into consideration all data in the dataset. So if I have thrown a die here again now, let's say I gotten this. So what will be the average of this dataset? Then I just have to add them. I add up all the values. Then I divide by the number of data I have in the dataset. In this case, it's 5. So this is 10, 16. Or 32 tenths. So this is 3.2. And often you can use the symbol, the variable, let's say x, and then put a line over it. So this is the symbol for average. So the average of this dataset is 3.2. So if you put them You can put them, if you put them in order, you don't have to do it here now, but 1, 2, 3, 4, and 6. According to average, the middle is here somewhere, 3.2. So that's the middle of this data set according to the average. We see here if I change any of these, then the average will change. The same is not necessarily true if for the other ones, the mode and the median. So we could write the formula now for average. So you take all the data in the data set. So this is the general formula for calculating average. We take all the data in the data set, add them up, and divide by the total number of data. So we get the formula for calculating the average. Sometimes you're given the data in terms of frequencies. So for example, frequency of data type U1 and frequency of data type U2 and so on. The last one, UM. If I'm instead giving frequencies, and these are maybe large numbers, then it's tedious to write a long numerator here to add them all up. Then instead you can use the following formula. So you take so many you had of data type 1 and multiply by data type 1. And the same way for the all other data types. And then you have to divide by the total number of data, and that's n. But n you can also write as a sum of these frequencies if you like. So this is an alternative formula. It's the same definition as this one, but just written in an alternative way. So when you're given frequencies, it can often be useful to write this. So instead of writing here means that you have gotten data type U1 if U1 times. Instead of writing it that many times, adding it together, you just take advantage of the multiplication, writing as a multiplication instead. So you can easily show that these two are equivalent, just written in two different ways. So let's take an example. So let's say that I have thrown a coin. So I can gotten two data types, heads or tails. So let's say that I have gotten 20 heads and 30 tails. Yeah, of course now I can't calculate with heads and tails. I have to translate heads and tails to numbers. So let's say I translate heads to a +1 and the tails I represent with a -1. Then I can calculate using this formula. What is the average then? Yeah, I have frequencies of heads is 20. And this is the data type head, and that's represented by 1. And then we have 30 tails. So 30 tails times the tails, and tails is -1. And now we just add up all the frequencies. So it's 20 plus 30. So means we have thrown the coin 50 times. So this is 20 minus 30. So this is -10 divided by 50. So this is -0.2. So in this case, the average is -0.2. So you see that the average is a little bit closer to -1 than +1. Of course, since we have gotten more tails than heads, this must be the case. So the middle of this data set, middle of having 20 ones and 30 -1s, the middle of that is at -0.2. Okay, so that's an example of using this way of writing the formula. Sometimes you're given instead the data as relative frequencies. So you have relative frequency of data type 1 or data type 2 and so on. In this case, you can use a third alternative way of writing the average. And you can just write it like this. You take the relative frequency of data type 1 multiplied by data type 1. And then relative frequency of data type 2 multiply data type 2. And so on. Up to the last data type. Okay, so what you will get in this case. First of all, this formula, you can easily show that it's the same definition as the other two. They easily follow from each other. Just doing some little algebra to prove that and are the same. So let's calculate now. Let's have a coin example again. So let's say that the relative frequency of heads is 30%. Okay, a little bit biased coin then, is only 30%. But in any case, so relative frequency of tails then will become 70%. And let's say that we represent this with +1. I represent this with -1 again. In this case, we can't use the other two formulas because we don't know how many times we have thrown the coin. So we have to use this formula. So what do we get if we use this formula? Then we take the relative frequency of the first, 30%, multiply by data type 1 is h, that is 1. And then we have the second one, relative frequency of that was 70%, multiplied by the second data type that was tails, and that was a -1. So what do we get? 30% is the same as 0.3. 0.3 times 1, that's 0.3. 70% is the same as 0.7. And 0.7 times -1 is -0.7. So this is -0.4. We didn't use the same data, so we didn't get the same result as in the last case. But this is, if we have instead this data set, we will get this average. So the average now is at -0.4, closer to tails than h, of course, since we had 70% tails, only 30% heads. So these are three different ways of calculating the average. And which one you choose, you can choose freely. So in this case, you had to choose the third one, but you choose the one that's most easy to use. So which of these types, median, mode, or average, should you use? It depends on the situation. In some situations, one is better than others. And so it depends completely on the situation. For example, if you want to represent, you have some ski jumpers, and that one of the ski jumpers only managed to jump 35 meters, but the rest of them lies in between, like 95 and 98, 101, 110, 111, and so on. This is just like a fluke accident. He maybe just fell or something. So this is not very representative. So in this case, it's natural to use the median, because you take the one in the middle. And which one is the one in the middle here? Is the average of these two. So the average will be here 99 point something. So that's the most natural one to use here. Using the mode is is pointless, because there's no one that's occurred twice. So there's no mode in this case, where there are several modes depending on the definition of mode. The average, of course, you could use. The average will be lowered significantly because of this fluke accident. So the average here will be, if we don't calculate, we just estimate it. Let's say that the average of this is 100, and this lowers, so maybe it's 90 or 85 or something. So we would have an average here, and that's not very representative of the center, because this guy who jumped here, he destroyed the statistics in some sense. So maybe in this case we don't want to include him, since it was a fluke accident. Was an outlier in the statistics. So in this case, maybe not so good to use average. But in other situations, it could be good to use the average and not so good to use median and mode. So it all depends on the situation. So let's say, for example, that we have a data set that we have 1, 1, 1, 1, and then we have 100, 100, and 100. If I use the median here, then I will get this one. So the median is a 1. And if I use the mode, it's also 1, because that's the most common one. But that's really forgetting about a significant part of the data set. So if I take an average instead, I will have something closer to 50. So the average here will be something close to 50. A little bit lower than 50 since we have more ones than hundreds. But so the average will be in middle. So if you take the average, it takes into consideration that we have larger ones and small ones. If you take the median or mode here, it's just like forgetting about we have the bigger ones here and only look at this smaller part. So this is maybe not so a good idea to use there. It all depends on the situation.